Dennis Schlepfer from Risk Application Schlepfer, and I'll show you how to process some airborne high-specs imagery with Atcor. And this will be this data set we're going to look into. That's a subset of data I'm going to show right now, taken in Norway by TerraTech company. And first, if checking the data, you have to check if also the scan angle file is available. So let's have a look at the scan angle file, which is apparently available somewhere. Here it is. And scan angle file looks fine. It's showing a cross track, the zenith angle in the first band and the azimuth and height. But for Atcor base processing, only the zenith angle, only the first band is used. So let's put this away. Next one is, if you're starting the first time, you have to define your sensor. So this has to be done only once. So you go there and define sensor parameters. One could choose an existing sensor. I'm going to choose the one I already have predefined to speed things up. So this is a high specs sensor. Where is it? With 186 bands. That's that one. So one has to select a sensor DAT file. Sorry, I have to go into it. So that's how you select it. And now let's see if everything is okay. It's a standard sensor, so I won't process with SMILE. Total field of view 14 degrees, number of cross-track pixels, and it has 186 bands in the reflective part of the spectrum. The scaling factor is 100, so in the cal file it will be a 100 number, and in here you have to show the factor which brings you back to the physical unit milliwatt per square centimeters, the radian microns. So you can still check it and maybe update the sensor. It will overwrite the cal file and it will overwrite the DAT file, and then it has been defined. Define the sensor does not yet define the spectral properties. So you have to apply the spectral shift. No, you have to generate the spectral functions. So I choose usually the NV header for that, and Butterworth order 2. For this data set, default full width half max of 1.5 was okay, and the output direction should be the sensor direction I have just been defining before. So that's this sensor directory high specs near that one. So now they have been defined. I overwrite existing ones because I checked this before already. So this is the output. Looks okay. Quit. And now the result can be run. This one creates the atmospheric database at the resolution of the current sensor. I choose the reflective sensor, choose my sensor directory, which is that one. And I only need the flight altitudes appropriate to my sensor. This will be between 1,000 and 3,000 meters. I show the selected files, looks okay, and now I can run the whole thing, which will take a few seconds, and afterwards I can go into the processing. So this resamples the spectral lookup table to the 186 bands of the visible near-infrared sensor, which is the sample data used in here.